Well, isn't it another time for us to get together on the SMC Journal podcast? Yes, I believe it is. Welcome to the show. I'm Scott Moore, where we talk about systems and software engineering today. We talk about performance, observability, and monitoring. We talk about chaos and resiliency, security, and everything in between. And today's show is about resiliency. We're going to be talking to Gremlin and how we mix performance and load testing with chaos resiliency testing and get more value out of that. We're also going to be talking about what Gremlin has been doing to change some of their products around just a little bit, like where they're expanding and where they're taking the products. So it's going to be a great show. Before we do that, let's talk about the sponsors that make this show happen. And one of the biggest sponsors that we have are Micro Focus, the makers of LoadRunner and its family, professional enterprise cloud and developer with the largest community of performance testers in the world. You might want to check out that QR code, which will take you to the LoadRunner family page. And there's some links out there for YouTube videos about performance engineering as well using those products. I've been using LoadRunner personally for over 25 years, and it has one of the largest sets of protocols that you're going to find in a load testing tool, as well as a great analysis engine. And they're coming out with new protocols all the time. So we're working with Micro Focus this year to kind of expand some of the messaging for them. And one of the things they wanted to talk about was how LoadRunner integrates with Gremlin. We talked with David McLeish last year about that, but we haven't talked with Gremlin about that. So that's what I wanted to do today. We're going to bring on Jeff Nikoloff of Gremlin to talk about just that very thing. So let's do it, shall we? Hey, Jeff, how you doing, sir? Welcome to the SMC Journal podcast.
Great. Thanks for having me.
Yeah, it's great to have you. I want to talk about Gremlin and some of the changes that are happening at Gremlin and resilience in general, because I've always emphasized performance, and now we hear words like efficiency now that people have moved to the clouds. But one of the biggest words that I keep hearing about that's most important to the C-level is resiliency of the application, whether that's a cloud outage or a pod outage in Kubernetes or what have you. And that's really where Gremlin's sweet spot is. And also, I work a lot with performance testing tools like LoadRunner, and I know that there's an integration there. So I really wanted to have you on to talk about that. And before we do that, though, I'd like to hear about you, who you are, and how you got involved with Gremlin.
Yeah, so I've been in technology about 20 years. I started in higher education, put myself through school, went on to work for a big network company, ran my own web shop for a while, joined Amazon in 2011, and that was like getting a whole second degree in engineering. Really changed my perspective on what it means to own a high mission critical service that is under continuous stress, right? And you can only you can only live so long under in a high operational burn environment before you really begin to develop deep opinions about platform reliability and resilience to random events and yeah. So that's really where I began my journey into a lot of this stuff. I left Amazon at the end of 2014. Ended up writing a book about Docker. Published 2 editions of that since, and started my own consulting company where I help people do modernization, move to the cloud. I kind of thought of it as like principal engineering on demand. It was pretty boutique type gig. But thinking about product management and helping people balance the pressures of iteration with the pressures of reliability, management, thinking about how to run engineering organizations and that sort of thing. Basically in 2020, when COVID hit, consulting dollars dried up, and really it was time for a new thing for me. So I joined Venmo as a senior director of engineering, or as a director of engineering and senior principal engineer, where I really basically did what I was doing for everyone else, but for Venmo full time. And by the time I left there last year, I was running an organization of about 120 people, and that included a lot of the SRE and infrastructure efforts for Venmo. Joined Gremlin, and basically because I've been familiar with their work for a long time, and have always been a big fan. And really, again, having lived in that high ops burden environment, want to do, that's a mission that making the internet more reliable place is a mission that I can very easily get behind.
Awesome. I'm wondering, why do you think, because as a software engineer, I've always wanted resilient applications. You always want there to be 31 things that have to go wrong before you even struggle with anything. You got backups to backups and everything. But why do you think resilience has become such a key word? Is it just because of the site reliability engineer title and everybody's thinking about reliability as this bigger thing than just performance and whatever? But what do you think it is that's making resilience and reliability so principal in people's minds?
Well, I think there's a balance here, right? And whenever I ask that question, because that happens all the time, you think like, how did we get here? I try to reflect on my personal, like professional journey. And I know that there was a clear arc where in the beginning of my career, I spent a lot of time thinking about how to make things work, right? And focusing on new technologies. What new can I do with certain things? How can I get into distributed systems? How can I think about systems in a new way and in like network-based composition, right? Really, really powerful stuff. But I think there comes a point in sort of, whether it's like, especially for service engineers, and like service engineers are very, very different. It's a different thing entirely from software engineering and standard programming, because you're responsible for the thing in operation. And that's kind of like the first time that really happens. Most other software you're publishing, and then someone else is operating it. And so you really, I think, end up thinking about quality and security and reliability and resilience kind of in a much more first person way. And so at some point you begin thinking more about the way things fail than how to make them work, right? Like how to make them work kind of becomes a foregone conclusion. Mm-hmm. And now it's like thinking about failure modes, thinking about different ways that the network can let you down. You're thinking about, transient state or volatile state in your system. Like I know that there's timestamps associated with my SSL certificates. And like, even though it's a good state today, it might not be tomorrow. Right. Or what happens if there's if we're handling more traffic? Like most of the time when we build systems, we build them with a specific kind of business context in mind. And if we're not careful about like really deeply understanding that context for which we design the system, we might like start exceeding those thresholds, right? So, back in the day, it was like, I mean, even today, 95% of the internet is run on like, PHP WordPress blogs, right? Which you can get away with like a standard LAMP stack, a single machine, the database is running there, the web server is running there, the app's running there. It's great. But most of those, sites are serving on the order of thousands of visits a day, maybe right. Tens of thousands of visits a day. But you start to get up to like 10,000 concurrent connections, and now all of a sudden you're like, okay, well, it's starting. We have too many active connections, or we're starting to overload the system. We need a load balancer. We need these things. And so that's just one of those like classic ways where the systems we build might not always be the right thing as our businesses change, right? So that's really, I think, and I do hope that it continues to grow as something that people are thinking about as a first class thing, right? Like because it does require a little bit more intentionality about like understanding the context that our businesses operate in, and that can be a challenge to keep track of. That there's a lot of different things, right? Like.
So that brings me to my next question, which is we've got these engineers, these really smart people at Netflix that one day decided, let's create some stuff where we push buttons we're not supposed to push, because they've got an application that suddenly became so popular, and it's streaming and it's critical and it's always under duress, it's always under load. So they had to figure out ways to, let's plan for this chaotic mess that's going to happen. And out comes Chaos Monkey and Chaos Gorilla and all these things. Yep. And from that, we've got a whole new subgenre of something out there that's not just about, okay, we're going to do performance testing and load testing on this to see if that brings it down. But now we're purposely going to do things while we're probably under load, messing up configuration files, changing DNS settings and things that would happen in production. And so this is really where Gremlin kind of comes into play and says, okay, let's kind of organize this into something that is kind of a more organized animal, an organized monkey, if you will, right? Is that
Yep.
the premise of Gremlin and what it's trying to do?
I mean, generally, the practice really predates Gremlin, and it predates what we were doing at, or what they were doing at Netflix, and it predates what we were doing at Amazon. And this is the sort of like classic pattern was, back in the day, like a sysadmin would walk down into the data center and unplug the network cable on a machine in a rack somewhere, and but that was generally a bad practice because it's not particularly repeatable. It's something that certainly could happen, right? I've worked in companies where we managed large numbers of machines, and sometimes things got unplugged, right?
Mm-hmm.
And so we've all kind of always been aware that stuff happens when we're doing this kind of work, and when you're responsible for operating these platforms. And so, but I think really there was, in the mid 2000s when we started getting a lot more API driven stuff, infrastructure or API based platforms for execution, whether it's the VMwares or that whole universe, or the AWSs and the public clouds, right? That gave us, I think, for the first time, the ability to automate these things in such a way that made them repeatable, and something that we had the ability to, once we've measured impact, revert, right? And so, very, very powerful stuff.
That makes a lot of sense, because when I think about how I address load testing specifically, you're trying to create the perfect storm, but you want it to be a recreatable perfect storm every time.
Right.
There is a bit, I've always said this, there's a bit of chaos in every load test where there's some randomization in there about how long pause times are between steps, how long virtual users pause before they start back up another iteration but at the end of the test, you still want about the same number of page views. You still want the same number of executions during that period. So you've got an apples to apples sort of test every time. And it seems like what we're doing here with Gremlin is the same thing. We're creating something that's recreatable. We're creating the chaos, but in something that can be recreatable, so we can figure out what is it that we need to fix first, right?
Right. Exactly. And really, there's a lot of different ways to do it, and there's a lot of, there's no wrong reason for it. I would say whether or not you want to validate, for me, it's more about validation. Like, we are asserting that we can survive or that we fail in a particular way when a specific kind of failure occurs, right? And so like, whether I want to validate my alarm configuration, I just want to make sure that I get paged when I should be paged, right? And that's traditionally something that's very, very difficult to do, right? That we put a lot of faith in our observability and alarming systems, because that's really like, if that fails, it doesn't matter if everything else fails, you'll never find out about it in the middle of the night
until the
right?
customer calls.
Until the customer calls. And like, if I mean, I don't know, maybe this is just the where I kind of came from, but like, man, if the customer notices that we're having an issue before I do, I've missed the boat, right?
Yeah.
Like, this is a really big problem. And so, but that's a very clear way. Like, it's very difficult to validate that without doing something like, without actually testing the failures. And so, like, and try to bring it into how this pairs with load testing, or with under real traffic load. It's incredibly important to test your systems under, like, the context that your systems are operating in is really, really important when it comes to how you are measuring your failure. For example, if I'm running, 3 instances of an application behind a load balancer, right? And I'm only running like 1 request per second in order to probe whether or not my service is still alive. I can take out 2/3 of that fleet, and I guarantee I will continue being able to serve that traffic, right? But if my realistic load conditions look like, the traffic is saturating, 90% of my 3 backends, and one of those goes down, even one of those goes down, and we're going to start experiencing problems, right? And so it's very, very difficult to, or I would say it's critical to create realistic load situations and realistic use conditions if you're testing in a pre-prod environment, when you're doing this kind of work, if you want to learn anything from it. Right?
Yeah, absolutely. Tell me about, as we combine these two, let me go ahead and go to this article here that I've got up about last year when Gremlin said they're now integrating with load testing tools, and one of the major integrations was with LoadRunner. There was an article that got released on your blog about adding chaos engineering and performance engineering together, and obviously that's really tiny writing, so I don't expect people to read this, but the point was you're now integrating these 2 products together. Talk about the value add that I get out of the analysis from LoadRunner, from not just LoadRunner alone, but the additional scenarios I can run with Gremlin involved. What kind of additional value do I get from that?
Well, from a LoadRunner user, if your shop uses LoadRunner in order to generate synthetic load on your services, and you're using that for performance testing, by picking up the Gremlin integration for LoadRunner, now you can use that in order to measure impact to those same services if there's a failure, right? And that really becomes you're sort of orchestrating the tests in such a way that tightly correlates with your performance test regimen, right?
Give me an example of something you would do under load. I've already created 100% load and everything's still rolling along smooth. What's Gremlin going to do under load that's then going to modify that test that'll give me more output?
Yeah, so once you have an environment under load that's operating like your production systems might, right? Then you can do things like trigger host failures. You can do things like say, what happens if we exhaust memory on a certain portion of our fleet? What happens if our Kubernetes-based platform experiences like some pods begin restarting, or or if we exhaust CPU, or a lot of like, or maybe if we introduce specific like network latency between nodes. It might not be that you're measuring a fairly simple application architecture where it's like the client, a load balancer, and then some fixed fleet of applications, right? A real architecture is going to look like client, a load balancer, some kind of like ingress, like first tier applications, maybe an API gateway layer that is maybe calling off a chain of internal services, or hitting like 2 or 3 databases either simultaneously or in sequence, one way or another. Fulfilling requests can get quite complicated, and so what Gremlin allows you to do is to, depending on your architecture, inject specific failures at specific points in that architecture to see how your application behaves, and you have LoadRunner sitting there, measuring impact from the client perspective, which is a really great perspective to see, right? Like we want to make sure that we as service providers, that we do everything we can to align our operational interests with our customers. So measuring it from the customer perspective is very powerful.
So I got to address one monkey in the room, because we talk about testing in a pre-production environment, but we could also do this in a production environment. And if I'm a CIO and I'm at the table talking about chaos, or whatever word we want to use that we're going to do on my production network, I could say, we've already got a lot of chaos on our network. What are you going to do to my network? What are you going to do to my applications in production with this product? How do you respond to that when they're like, look, I don't want anything to mess up our production network. You're always going to be limited to pre-production. Is that the best practice, or do we need to do this in production to see how it's really going to behave?
Look, I mean, I'm not here to tell anyone that they have to do anything. Personally, I'm a very strong believer in testing in production. I do think that, I was on stage at DockerCon a handful of years ago and demoing a chaos related tool that I built for a hack day. And in explaining chaos to the audience, I shared my philosophy that if something can happen, it's actually really important that it happens semi-frequently in order to help you prioritize fixing that thing. Otherwise, you'll never be prepared, right? Now, depending on the shape of people's business and the impact of specific outages or like the kind of failure you're planning on injecting, I could totally understand how people would not want to test in production. But it really comes down to, for me, the cost of building pre-production, production-like environments and simulating realistic traffic is, and building, like, there's a whole aspect you get into, like, around data cataloging and having production like data in the databases when you're accessing it, right? And like that is a whole like hard thing to do well, and it can be extremely expensive,
Very expensive and resource intensive and long time
resource intense. And I kind of point, like, again, I'm not going to push anybody if they don't want to test in production, like that, and if they would rather spend the money in order to be able to gain insights in a non-production environment, go for it, right? Like, I will support you any way I can in that pursuit, but you have it for free in production, right? And really, like, the main feature about using a platform for fault injection like Gremlin is that we fail safe. Like, this is having this tightly and purpose built, or this tightly coupled and purpose built platform for fault injection gives you the ability to stop the fault immediately when you see impact, right? And so, the alternative is if you're not doing this kind of testing, it will happen eventually, and when it happens, who knows how long the impact will take?
Yeah, you
right?
just won't be prepared, and it won't be controlled. So I'm at my one-person IT shop here, right? I come in this morning, have not changed anything. Nothing's working. All right. I'm like, what? Because I have Wi-Fi access, but I also have everything hardwired network. So just humor me for this story for a moment. All of a sudden, there's no networking. I'm like, okay, well, I'll connect to the Wi-Fi. I go to another computer. Network's down. I'm looking over at my switches. I see the lights on and all that stuff. Everything's working good. I'm like, I know what it is. I've got an interview with Gremlin today. There's a Gremlin in here. One person shot. No, what it turned out to be was I've got the weakest link was my Ethernet switch is about 10 years old, and it's sitting there. The lights are blinking, but nobody's home. So I unplug the power thing, just recycle the thing, and voila, everything's working again. So yeah, there's an industrial switch on the way from Amazon.com right now overnight as we speak. It'll never happen again. But that's the kind of stuff. I wasn't prepared. I should have done that. I should have already prepared for that, right?
But like the thing is, there's it's always there. Like the number, like, our systems are all very, very complex, and they're all doing a lot. And there's always a lot of weird state building up that you don't think about, that we rarely model, right? And so, it could be, in your switch, in your, in the switch that you had, that there's a log file that's just been, appended to in memory happily for 10 years. And then all of a sudden it went to write a log line this morning in the memory, and it was out of space. Yep. And so, like, these, like, I it might also be happening in the industrial switch that you've ordered, right? Like, I would say, but it's, I think there's a couple things that I really want to leave people with in general, which is, like, number one, our systems are way more complicated than we give them credit for. that in general, it's okay to make a lot of assumptions about steady state behavior, right? What they're going to do on the day to day, and to have a good idea of what like normal operation looks like. But that if something can fail, eventually it will fail. And
Yep.
I would personally have that happen just a little bit more often, so that I can understand what it is, so that I can figure out how to react to it, and just make those maybe even just human operations a well modeled part of how I operate. Um, does that make sense?
It does, but now you've made me paranoid about the enterprise switch that I've ordered. Now I'm just, so I'll order two different brands, and I'll have a backup to a backup. No, let's talk about Gremlin and some of the changes that have happened over the last few months, because I know there's been some platform rearranging and different things. So can you talk to that, kind of where Gremlin's at now and where you're planning on taking the product?
Yeah, so there's two big launches for Gremlin in the last 6 months now. One, and probably the one that requires the least explanation. We've launched trial program. So anybody who wants to come in and get a trial of Gremlin, specifically, our new product, is free to do so. I think that's free for 30 days if I'm not misspeaking, but check out the website for details. But yeah, anybody can come in, grab an account, kick the tires, install it on one of your systems. Again, this is all fail safe, and start to get a feel for what you can do with the platform. That's readily available. The second thing is a new perspective and the next evolution on what we were thinking of as chaos engineering, and really experimentation. So like Gremlin has a world class fault injection platform, and that's here to stay. It's getting better all the time, and for those engineers who want to dig in, who want to get surgical with the types of experiments that they're running, this is really the best in class way to go with it, right? But what we've seen in our most successful customers, right? We have a lot of experience, as a company, but also as practitioners doing this at a lot of very successful and what a lot of organizations with mission critical systems. I'll say that, right? And so what we've seen a couple common patterns around sort of that next level up from the experiment in our most successful cases. And what we've really found is two things. You can get probably 80% of the value, right? And solve your 80% of the most common failure modes with a really well-known set of tests. And our new reliability management product has those tests built, right? So our goal is to make operating your fault and your reliability program, whether you call it chaos or whatever you want to call it, operating your program, we want to help you make that as repeatable as possible and measurable as possible. So what the reliability product does is a reliability management product is it allows you to model your service software or the applications that you run inside Gremlin, and then we go ahead and wire up all the tests, and then give you the ability to one-click launch tests. We also measure the result of those tests, and so with the fault injection product, it's sort of like on the consumer to figure out, did we perform the way that we wanted to, right? There's a lot of room for interpretation. In the reliability management product, you can hook up a huge array of possible health checks, and we begin watching the health checks. And if at any point the service becomes unhealthy, we immediately stop the test, let you know. And then so for that catalog of tests, we roll all that up into a score that anyone can understand, right? And really that score, the reliability score, becomes a really good proxy for the amount of risk in your system, right? And so if you're doing something advanced, like a failure mode and effects analysis or something like that, you have this really good proxy number that you can use for probability of failure, and that's extremely powerful. And like, and we know that that's something that people can do and probably should be doing if they really want to manage the risk in their system. Then that's the number that they need. So we went ahead and rolled that up for you, so we can say, hey, like, concretely, here's where you stand today, and provide you that single pane of glass for, of all of our services, which one's the most risky, where do we want to invest, and really drive those technology investment decisions. So we're really excited about that.
It sounds pretty cool. I'm wondering, still the vision to continue to integrate with products like LoadRunner and load testing tools
Absolutely.
like that to keep that going. So that's still an ongoing
Absolutely.
thing.
Yep. All of our APIs are exposed as usual. And, that's we want to facilitate those integrations anywhere we can.
Sounds good. Well, great. This is I've learned a lot today, and I'm going to get more switches. Thank you so much for being on the podcast today, Jeff, and hope we can have you on again.
Really appreciate it, Scott.
All right. So I hope from this interview you've come to the conclusion that using a product like Gremlin is not just automating somebody pulling out a network cable. That's not really what this is about. This is a more sophisticated technology that allows you to get more value together from load testing by seeing something under load and preparing ahead of time and to know what to do. Even in our military, they drill all the time for things that may never happen, but they're always prepared for that. And for some mission critical applications, you need that same level of discipline. So from that, I think that chaos testing, resilience, and the engineering around reliability, I think it's solid. I think you're going to hear more about it this year, and I think it's necessary because we're still seeing problems with entire cloud outages, right? We had an Azure outage earlier this year, affected Outlook and Teams and all these things from Microsoft, and I got a feeling we're not done with all of that. Thus the reason we're beginning to talk about multi-cloud, hybrid cloud, super cloud, where you're going to hear more and more about that. Some of the same things I talked about in my 2023 predictions and trends we're hearing from that. And I think resiliency engineering is one of those things that is going to be on the table this year a lot. What do you think? That's what I want to know. I am available by several different paths through social media. Either scan the QR code and check out my bio, or look me up on LinkedIn, Twitter, Instagram, and other places, or you can just send me an email to heyscott@smcjournal.com. Would love to hear from you. If you like this content, ring the bell and tell YouTube's algorithm that, hey, this is a cool site. We like you. Subscribe to the channel so that you'll see more and more of these videos as I put them out. And let me know that I'm doing the right thing. Would love to hear your feedback, too, of what you'd like to see on this show next. What type of things should we cover? For this episode of the SMC Journal Podcast, this is Scott Moore thanking you again for watching, and we'll see you next time. Bye.